Hey guys, today we are going to be doing polyprotic acid practice. So for this one, we are going to be doing a triprotic acid. So the acid is H3ASO4. Well, that's my dog. And it asks you to calculate the pH, given that it's a 1.00 molar solution. And they're also giving you three things: your Ka1, Ka2, and Ka3. I actually have not looked at this problem yet. I was doing it on a video and I paused it. So bear with me. 8.0 E negative 8 and 6.0 E negative 10. They're successively getting smaller, which is what we would expect from this problem. So the first thing I do in these type of problems is I write out the equation, which is going to be H3ASO4 plus water is going to dissociate into, or form and dissociate, I guess, H2ASO4 plus my hydronium ion. And I'm going to write my equilibrium expression. And my equilibrium expression will say, I'm going to use my Ka2, Ka1 is going to equal H2ASO4. I feel like my dog's about to howl. Wow, I was right on time. H3O plus over H3ASO4. And I'm going to do my ice table once again. I'm going to use the law of assumption, or the 5% rule, to say that the Ka1, 5.0 E negative 3, times my concentration of, which they told me was a 1.0 molar solution, is going to equal x squared. So the square root of that multiplied, square root of 5.0 E negative 3 equals x, which is going to equal 0.0683, which, as we can tell, is the concentration of my H plus. Now, they're asking me to calculate the pH. Now, pH is equal to negative log of the concentration of our H plus, right? So our pH here is going to be 1.17, which the reason that you don't necessarily, the reason that I'm not necessarily writing down the Ka2 and the Ka3 reactions is that because the dissociation constants for the Ka1 and Ka2, I should use my laser, are so small, when I find these x's, which are going to account for my H3O pluses, and I add them to my overall pH, it's really not going to change. And two, the idea of pH. So pH can range anywhere from negative to 7.00, and then beyond 7 is a base. So for an acid, this is a reasonable pH. As long as it follows the range, then you're fine. Yeah.